Okay, so the next thing I'd like to talk about is what is called the IID assumption in statistics. Okay, so what does IID stand for? It stands for independent and identically distributed. Okay, so what does this mean? Right, so as I was saying, so the general thing is assumption statistics is that you have data. Let's think of them as points, and let's call them x1, x2 to xn. Okay. Now, what you assume is that these data points, so these are actually independent samples from the same unknown distribution D. Okay, so this is D, this is just a fancy D written like this. Okay. And if you don't like the notion of a distribution, think of it as the same probabilistic process. Okay, so output of the same probabilistic process, random process, but done independently. Okay, so each point is generated independently, but each point is generated from the same random process. And this is one of the most common assumptions in statistics. Okay, that your data consists of independent points. Right. So this is good for certain kinds of data. Right. So suppose I have a bunch of points. Okay, and let's say the order doesn't really matter. So I have point 1, point 2, point 3, point 4, 5, 6, so on. You could imagine a random process that either picks a point around this center or maybe picks a point around this center, and let's say each happens with the same probability, half. Okay. So now this sort of model or this kind of a random process would generate this set of points. Okay. But on the other hand, so for this kinds of data set, this is a reasonable assumption. So this is a good assumption. But on the other hand, let's say you have some kind of data which is, let's say, a time series data. Okay, so I'm trying to give examples of when IID assumption is bad. Okay, so let's look at time series data, right? So you have x1 is, let's say, the stock price is the price of a certain stock at a certain time. X2 is the price of that stock at time 2. X3 is something else. X4 is something else. Okay, now this will have some jitter. Okay, and this can vary around in times of a crisis. Maybe it'll fall down, then it'll go up, and so on. But note that xt is not independent of things like xt minus 1. And so xt is pretty close to xt minus 1. And by no means is xt independent of xt minus 1, for example. Right? So it's pretty correlated with xt minus 1. Okay, so the IID assumption is a bad assumption for data of this kind. Okay? But it turns out that for many different assumptions, it's actually quite good. Right? So for example, the textbook has this example of measuring the speed of light. So Michaels and Morley, they had this famous experiment in the 1800s where they measured the speed of light. and they each time they measured the speed of light, they would get some value, which typically maybe was somewhere in a certain range. Then the next time they would run the experiment, they would get a certain value. But these experiments were independent of one another. So whatever error was introduced by some measurement process, you hope that it would cancel out, and taking the average would be a good estimate of the mean, right? So, but the point is that whatever measurements they got were all independent of one another. Okay. So, and in data mining and things like this, machine learning, this IID assumption is one of the most common ones. Okay. So this is something that we will keep in mind, and we will keep using. Okay, so these are the couple of things I would like to say about the modeling. Okay, so often in statistics, we would like to build models for data, and the most common kind of a model is this IID model, where you have some random process or some distribution D, and you assume that your data can be modeled as independent samples from this distribution D. Alright, so the next thing I'd like to talk about is a very simple question. So what is a statistic? So one thing to note is that the word statistics is just a plural of statistic, which has a very concrete meaning. So what is a statistic? It's something very simple. You have a bunch of random variables. Think of them as your data points. Right? So we have a collection of random variables. I will call them random samples. Okay, and these I will denote x1, x2 to xn. And assume for now that they are generated as before, generated from some random process. They may or may not be IID for the purpose of what I'm going to define. Okay, so what is a statistic? A statistic is simply a function of these numbers. Yeah. So this could, if they are numbers. So a statistic is simply a function of x1, x2 to xn. Function t of x1, x2 up to xn, denoted t of x1, x2 up to xn. Okay, and that's it. Okay, so these are random samples. So each one is a random variable. So one thing to note is that t itself is a random variable. Okay, so now hopefully you can see why we spent a lot of time in the course talking about functions of random variables, how you compute expected values of these, and so on. Okay, so you can appreciate why we were doing that, because we were leading up to things like this. Right, so a statistic is simply so it is itself a random variable, and it's a function of x1, x2 up to xn, which we call the random samples. Okay. So what are examples of this? So these are examples of this I'm sure you've all seen. The simplest possible statistic you can think of is the sample mean. So the mean is a statistic. So, and this just is what you all know. Okay, and then there are other statistics that are also very common. One is the median. So the median is the middle element. What does that mean? Okay, so this just means that suppose I were to sort these numbers x1 through xn. Okay, so let's say the numbers I have are 5, 10, 15, 4, 3, 18. Okay. Then the median of these, for now let me have an odd number to be simpler. So, and let's say I have 17. Okay. So to find the median of these numbers, what I would do is sort them and take the middle element. Okay, so get 3, 4, 5, 10, 15, 17, 18. Okay, and I have 7 numbers, so the middle element is 10. Okay, and if we have an even number, then usually you define if the number of elements is even. We define the median to be the average of the middle two elements. Okay, so this is just a notation, right? But the point is that the median is essentially the middle element of in the sorted order. So other common statistics include quantiles, okay, or percentiles. Okay, so these two are basically the same thing. Usually in quantiles you say that it's 0.2th quantile or something, where in percentile you would call the same thing the 20th percentile. Okay. And this is a number, so it's a generalization of the median, where instead of picking the middle element, let's say you put them in sorted order, in increasing order, and now you take the element that is roughly in the 2 out of 10th place. Okay, so that would be the 20th percentile. Okay, so this is another common example. So these are what are called quantiles or percentiles, and this is another simple example of a statistic. Okay, in general, you could have much more complicated functions, and anything would be a statistic. Okay, and a statistic is simply defined as some function of a collection of random variables x1 through xn. Okay, and the study of these kinds of statistics and what they say about the probabilistic process, that is basically the area of statistics.